All right, well, let's get cracking. We are going to talk tonight about solving linear equations, and you should be reasonably familiar with solving very basic linear equations. So stuff like this is what I would consider a basic linear equation. Okay, how do I solve that? Yeah, I just subtract 7 on both sides of this equation. And there we go. X equals 3. Okay, that one's pretty basic. I even think you should be able to handle a little more complex equations like this. How about that? This is a two-step equation. How do we solve this one? That's a good idea. Let's do plus 5. So we get 2x equals 8. And we're still not done. We still don't have the x isolated, so what will we do next? Let's divide 2. That sounds good. So these are 1- and 2-step equations that you should be reasonably familiar with, if nothing else, just from the previous semester of the class. What we're going to do is we're going to take some of those properties that we learned last week, and we're going to apply them to some of these problems to do some fairly complex linear equations like this one. Ooh, lordy. Man, that is a mouthful. So when you're solving an equation, the one goal you should have in the back of your mind at all times, the thing that you really would like to do, is to get x all by itself. So right away we have a couple of issues with this problem. Issue number 1 is we got x here and we got another x over here. So at some point we're going to have to get the x's together where they're both on the same side of this equal sign. So that's one of our issues, is we got the x's separated across the equals. Another one of our issues is this set of parentheses here that we're going to have to deal with. And then we've got numbers all over the place, just plain old constants without an x. So we got a 5 and a -1 and a 2 and a 6. And at some point, all of those are going to have to be moved on the same side of the equals as well. Our ultimate goal here would be to get x on one side of the equals and everything else on the other side. So for example, we might want our x over here on the left side and every other number over here on the right. And just like we did on these sort of simple problems, one of the ways that you can move things from one side to the other is through subtraction, addition, or division. Those are all ways that you can get rid of numbers that you need to move from one side of the equal sign to the other. So when we take a look at this problem, the thing that really bothers me the most actually is the parentheses. I'm going to go ahead and get rid of the parentheses first. So refresh my memory from last week. How do I handle a 5 out in front of a set of parentheses? Yes, sir.
Well, we do that thing where it's distributive.
The distributive property sounds perfect. So the distributive property says to take the number outside the parentheses, which is 5, and multiply it by everything on the inside. So we'll do 5 multiplied by 3x. That is 15x. Bring down the minus sign here. And then we'll do 5 multiplied by 1, which is 5. I'm going to leave the rest of the problem the same for now. So I'm just going to do plus 2 equals 12x plus 6. That already kind of makes the problem look a little nicer, not having the parentheses. Now, before I get into my ultimate goal of moving the x's on one side and the numbers on the other, do you see anything on the left or right side of the equal sign that can be combined after that step? There we go. How about these two? The -5 and the +2. Those are both constants that can be added together. Let's do it. So that would give me 15x, and the -5 plus 2 is -3 equals 12x plus 6. All right, I feel pretty good about that. Nothing else we can combine here, so now we're at the stage of the problem where we need to collect the x's on one side and the numbers on the other side. It doesn't matter which order you do this in. You can move the x's first and then move the constants, or vice versa. It does not make a difference at all. Generally, I think it's accepted that you put the x over on the left side of the problem. You don't have to do that. I'll show you some in a little bit where you don't. But generally, we try to keep the variable over on the left side and the numbers over on the right. So I think I'm going to take care of these variables first. I'm going to get the 12x out of the way, get the 12x moved over to the other side by subtracting 12x on both sides of this equation. Like so. So 15x minus 12x is 3x. I'm just going to bring down this minus 3 right here. The 12x's are gone. 12x minus 12x is 0. And then I'm going to bring down this positive 6. I'm going to actually slide it over here. Then what? Yeah, I think adding the 3 is a good plan. Let's get the constants collected over on the right side. If we're going to have the x's on the left, let's put constants on the right. So I'm going to bring down the 3x. The minus 3 and positive 3 are 0, so those are gone. And over on the right side, 6 plus 3 is 9. Now, my ultimate goal here was to get the x all by itself. Have I done that?
No,
No, I haven't. Why not?
you have one more operation left,
I do have one more thing over there with the x. What's the one more thing?
the division.
That 3 right there needs to be divided. So let's take care of that. Divide by 3, divide by 3. 3x divided by 3 is x, and 9 divided by 3 is 3, and there is my solution. Now I feel pretty okay about that solution, but I'm not 100% sure that I've done it correctly. Is there a way for me to check my answer and make sure that it's right? And the answer is no, you're just going to have to go with your gut. Oh, I mean, yes, there is a way. Here's how you check your answer. You take the original equation. Let's copy it right here. And you replace all of your x's with that number that we came up with, which was 3. So I'm going to rewrite this equation, but everywhere I have an x, I'm going to put a 3. So I'm going to do 5. And instead of 3 times x, I'm going to do 3 times 3 minus 1 plus 2 equals. And instead of 12 times x, I'm going to do 12 times 3 plus 6. And now it's not even algebra. Now it's just arithmetic. I just got to figure out what the numbers are. Your dear Aunt Sally tells you the order that you need to do things in. So over here on this side, I got to do what's in the parentheses first. And what's in the parentheses is 3 times 3 minus 1. So what's 3 times 3? 9 minus 1. So this is going to be 5 multiplied by 8 plus 2 equals 12 times 3 plus 6. So with the parentheses taken care of, what does Aunt Sally tell us to do next? Yeah, multiplication and division. I don't see any division, so let's do multiplication. 5 times 8 is 40. 12 times 3 is 36. I'm going to do the multiplication on both sides. Next, Aunt Sally says do addition and subtraction. There is no subtraction, so we'll just do addition. 40 plus 2. Good. 36 plus 6. Now, because the two sides of this equal sign are the same, that tells us that x equals 3 was the correct answer. And that's how you can check your work. If those two sides of the equals end up being different, if I end up with something like 42 equals 9, that would tell me x equals 3 was not the correct answer, and I would need to redo the problem and rethink my life. Or maybe just redo the problem. Okay, Now, I certainly don't expect you to check your work on every single one of these. As you can see, it's quite a lengthy process, but if you're doing a tough problem and you think to yourself, I don't know if I got that right, I might have messed up, there's no shame in checking your answers. It's better to take an extra minute to check your work and know you got the right answer than to not check your work and be doomed forever. I mean, and get the problem wrong. Probably not forever. Cool. Okay, so let's do one that's got a whole bunch of negatives in it. What should we do first? Looks like we got a set of parentheses. And what's in front of our parentheses? A 9. So let's do distributive property. 9 multiplied by 5. 45. And then 9 times x is 9x. What goes in between them? Minus, yeah, there's a minus in the parentheses. Minus right there. Equals negative 3x. Our ultimate goal is to get the x by itself. There are 2 ways that I could do this. What's one of them? Sure, one of the ways I could do it is to move this minus 9x over to the other side with the 3. What's the other way I could get the x's together? Yeah, I could take the 3x and move it over to the other side. Now, in both cases, it's addition. To get rid of minus 3x and move it over to this side, I would add 3x on both sides. And same thing here, this is a minus 9x, so I would add 9x onto both sides. So I can do either one of those. The question is, which one's going to be easier?
Adding 9x, because then you would have the rest of the 45.
Yeah, exactly.
Excellent. What she said was adding the 9x to both sides is a better idea because then you don't even have to mess with the 45 at all. I assume when you say don't mess with the 45, what you mean is if I moved the x over here to be with the 9, if I move the 3x over, now I got the x's on this side, I then need a step to move 45 to the other side. Right? If I collect the x's over here, I don't got to worry about it. What's another reason adding 9x is really nice? Yeah, I don't have any negatives anymore. If I have a negative 9x and I add 3x, that would give me negative 6x. I'd still have to deal with a negative. Now, dealing with negatives is fine. There's nothing wrong with the negatives. But if I can avoid them, why wouldn't you? So over here on the left side, I have the 45, and the x is canceled. Minus 9x plus 9x is 0. And over on the right side, negative 3x plus 9x is 6x. Now what? Division. This is called the division property of equality. That says it's okay to divide both sides by a number. What's 45 divided by 6? 7.5. 15 halves would also be acceptable if you wanted to just reduce the fraction 45/6. Now this answer's okay, but we're really used to having the x on the left and the number on the right. I'm going to switch these. What property allows me to switch the order here? Which property that we learned last week says it's okay to flip it? If A equals B, then B equals A. Which property allows me to do that? The reflexive. Oh no, I'm sorry, I lied to you. That's a symmetric property, isn't it? Reflexive is the multiplication one, sorry. Symmetric property. Do you need to know the name of the property? Not really. But why would you not want to? Clearly, you don't need to know the name of the property because even I messed it up. Anyway, if it comes up on Final Jeopardy, though, you want to be prepared. Not strictly a requirement for you to put it in that order, but a good habit to get into. You never know when you're going to be at your next math party, and you're going to need to put that in the correct order. Oh, Bryce, a party is when a group of people get together that have common interests. They do something together usually. Sometimes there's music and food. And in case you didn't know, that's what a party is. Okay, I didn't want to assume. Let's do one with fractions. I'm open to suggestions other than let's just quit and copy off the kid next to us.
No kidding.
Don't be afraid of fractions. Fractions are people too. Our goal is still the same. Get the x by itself.
The 1 and the 4. Add the 1.
Okay, so you're trying to be sort of a chicken and do the easy part first. I respect that. Let's add the 1 on both sides so that we've got the numbers collected on the same side of the equals. So that's going to give me 5/2 x equals 3/2 x minus 3. Then what? So you might be thinking, boy, this problem sure would be way nicer if it was not fractions. If these fractions were gone, that'd be a 5x. The next one would be a 3x. Man, I sure would like to just do that problem instead. I've got good news for you. You can just do that problem instead. If you multiply the entire problem by the lowest common denominator. Lowest common denominator is something that you learned about when we talked a long time ago about how to just add and subtract fractions. You had to have a common denominator. We even came up with a cool abbreviation for it. It's called the LCD. I guess it's not that cool of a definition. Okay, so what this is telling us is if we could multiply by the lowest common denominator everything in this problem, the fractions would go away. So that becomes the question, what's the lowest common denominator? So let's talk about the denominators. What's the denominator of 5/2? 2. What's the denominator of 3/2? Also 2. What's the denominator of 3?
1.
What is the lowest common denominator of 1, 2, and 2? 1.
No, common. Most common.
Oh.
If I multiplied every single number in this problem by something, what is the something that would get rid of all the denominators? And the answer is 2. Let me show you why. If I multiply every single thing in this problem by 2, this is what the problem's going to look like. I will have 2 times 5/2 x equals 2 times 3/2 x minus 2 times 3. Every single thing in this problem gets multiplied by 2. Why is this a good thing? Looks like we just made it way worse. But check this out. Here's how you multiply a fraction by a whole number. What's 2 times 5? 10 divided by 2 is 5. So this is 5x. 2 times 3 is divided by 2. So this is 3x minus, and this one's really easy, 2 times 3. God bless you, my child.
Thank you.
By multiplying everything by 2, No more fractions. Now the downside of no more fractions is these numbers are a little bit bigger. We had a -3 on the end and now we have a -6. It's a little bit bigger. That's the price you pay for no fractions. So if you're cool with fractions, be like, I don't mind fractions, I'll subtract them, I don't care. Then there's no reason to do this step. Just deal with the fractions like a real man. But if you're like, I hate fractions with the burning fire of 1,000 suns, I refuse to do math with fractions, multiplying through by the lowest common denominator is a good way to get rid of those. Now that you got it set up here, we're home free.
So you only multiply the numerator and then divide the denominator.
Exactly right. Exactly right. And if you do it right, your fractions should go away. What's that?
I'm feeling I want to fail.
You have a feeling you're going to fail the final? It's like the 4th week of class. I'm going to need you to be optimistic for a little bit longer. I'm going to need you to make it at least halfway through the class before you start lamenting your life choices. Let's divide by 2. And there we go. Well, if you fail the final, look on the bright side.
What?
Oh, I don't know. You look on the bright side. I got nothing.
Wait, so if I fail the final and I just fail everything, the whole class after each class,
What's the worst thing that could possibly happen?
that
What?
I have to retake the class.
Really? Taking math twice is the worst thing that could possibly happen? You don't have a very good imagination.
Having to pay for the class again.
Oh, you got to take math and pay for it twice? That's worse.
Yeah, that's a bummer.
Yeah, yeah. Your GPA drops so low they won't even let you take classes anymore, so you have to remove yourself completely from college.
That happens.
Then nobody else will hire you to work a job, so you're unemployed and
That
homeless,
is a
and
bummer.
and you end up panhandling on the side of the road with a tin cup, begging for spare change for the rest of your life. See, that's worse. All right, pep talk over, kids. I'm sure that's not going to happen. I'm just giving you worst case scenario. See, anything better than that is an improvement. See, no matter what happens now, you're going to be like, man, that was rough, but it's not like I got evicted from my home and I'm on the side of the road now. See? The power of positive thinking. You are welcome. Now, what's the best thing that could possibly happen? See, you're thinking too small. Best case scenario, you don't have to take. So worst case scenario is take math. Best case scenario is don't take math. I feel like you're thinking too small. Thinking too small. Shoot for the stars. Okay, so let's talk about this problem. Why do we hate it?
Fraction.
It's got a fraction, for God's sake, man. I hate fractions. Who's with me? How can I get rid of that fraction? Well, let's think about what a fraction is. When you have the line and the number 3, what does that mean?
Division.
It means divided by 3. That's exactly right. So this is 2 multiplied by a plus 3 divided by 3. How do I get rid of divided by 3? What's the opposite, the inverse of dividing by 3? Multiplying by 3. So let's do that. I'm going to multiply both sides by 3. I'm going to write this out as a separate step because I don't want you to mess it up. Multiply both sides by 3. I want you to be very careful here. So here's what the left side's going to look like. It's 2a plus 3 over 3 multiplied by 3. And the right side is going to be 6a plus 2. I'm going to make a mistake here. I'm going to make a mistake. Can you tell me what the mistake I made was? I just made a mistake when I multiplied both sides by 3. What is it? I didn't do the parentheses. Parentheses where?
On the top.
Oh, I should have multiplied this first? Yeah, you're probably right, but I won't get the wrong answer if I don't do that first.
You won't?
I made a mistake that's so bad I'm going to get the wrong answer if I don't fix it.
Oh.
Parentheses around 2 and 3.
Close, but no. Look at the right side. Am I multiplying the right side by 3?
No, you're doing it by the right.
Go ahead. Yeah, I would. Why do I have to have these parentheses? Because without them, I was only multiplying the 2 by 3. With them, I'm now multiplying both things by 3. Have to have those parentheses. Okay, so let's go and work this out. Now, here's the good news. I'm going to see if you can work this out without us writing anything. Here I'm going to do 3 times 2, which is 6, and 6 divided by 3 is going to give me 2. So what's really happening is that this 3 and this 3 are, I don't really want to say canceled out, but they divide to 1. 3 over 3 is 1, so that's why I'm allowed to cross those out. So what I'm left with over here is just 2a plus 3. Equals, this is 3 times 6a plus 2. It's fine to write it the way that I wrote it, but I'm going to write it like this with the number in front. It's the exact same thing. I just think it looks a little nicer with the number in front, like that. Okay, where did I lose you?
The whole question.
Okay, so this is a 2. It's more than 1, but it's less than 3.
Okay, so when you
Oh, the crossing out part. Okay, great. So this right here?
yeah.
Okay, I'm going to take just this piece. And I'm going to work this out on a separate piece of paper. Just that piece. I had 3 times 2a plus 3 over 3. Agreed? Okay, let's do just this part. So if I did this the long way, this is what I would do. I'd do 3 times 2, which is 6, right? So I'd have 6a plus 3 divided by 3. Now what would you like to do next?
Oh, so you do the top.
Distribute the top? Okay, so 6a plus 18. Like that? Everybody happy with that so far? This can reduce though because 6 and 18 can both be divided by 3. So what's 6a divided by 3? 2a. And then 18 divided by 3 is? Does that make sense? Feel okay about that one?
Okay.
Yeah? Okay. Put a pin in this. We're going to come back to it in a minute. Here we are solving this problem. Let's go ahead and distribute. Let's distribute this side. 2 times a and 2 times 3. Oh my gosh. Hey look, it's 2a plus 6 both ways. It came out the same. So when we go back and look at this, the question we should be asking is, was there a point in this problem where I could have cut out some of this math and just gone straight to the 2a plus 6 now that I know that's the answer? One of the ways you might have seen it is right here. We distributed the 6 and then divided by 3, but it's okay to divide by 3 first. 6 divided by 3 is 2, so this could have been 2a plus 3, right? If I'd done 6 over 3 and divided that first and then did the distributive property to get that, does that make sense? That's what we did here.
Yep.
2a plus 3. If you back up even farther, you could be like, oh, well, I could have just crossed out these 3's, and there's the 2a plus 3. What's happening is I have a 3 on the top and a 3 on the bottom. Anything divided by itself is 1. So this is 1 times 2a plus 3, which is 2a plus 3.
Or 1 divided by 2a plus 3.
Don't think I agree with that. 2a plus 3 divided by 1. I wouldn't say 1 divided by 2a plus 3. Regardless, more distributive property. 3 times 6a is 18a, and 3 times 2 is 6. Okay. Now what?
Start getting A to one side.
A to one side. Now, does it make more sense to subtract 2a on both sides or to subtract 18a on both sides? I agree. Subtracting 2 makes more sense. You can do either one. Either one will get you the correct answer. So if either one will get you the correct answer, why do we care that we're subtracting 2a instead? What do we gain by doing that? Well, we are getting the a on one side, but we would have got that if we'd subtracted 18a, wouldn't we? No negatives. Exactly right. We have the same attitude towards math as we do towards our friends. We don't need negativity in our lives. Now what? Let's subtract 6. This is going to look a little weird. That's 0. 6 minus 6 is 0, as it turns out. Okay. Divide by what? I want the a by itself, so let's divide by 16. What's 0 divided by 16? No, you're thinking 16 divided by 0. 0 divided by 16 is 0. So after all that work, the answer is, let's go ahead and use our symmetric property. A equals 0. That was a lot of work to get 0 for the answer. How about that? 2 problems in a row with fractions. Boy, I tell you what. I sure am glad that none of these problems get harder than that. What a relief to know there's nothing worse than fractions. What a relief! Now, I'm sure you're all thinking the same thing I'm thinking, which is, I love fractions. I'm so excited that we get to do this problem. Right? Everybody was thinking that with me?
Sure.
Fractions are my favorite. Okay, you might have been thinking, I hate fractions. I want to light my notebook on fire and walk away in slow motion. I have good news for both of those groups of people. If you like fractions just fine, you can solve this problem using fractions, just like we've solved all the rest of them. It's not a problem at all. I got good news for the fraction haters too, which is that we have a technique to get rid of the fractions, just like we had a technique to get rid of, we have a technique to get rid of the decimals, just like we did the fractions. So if you hate decimals, we can solve that problem. In the words of the great philosopher Mahatma Gandhi, if you got a problem, yo, we'll solve it. One of the things that you can do to get rid of decimals is to multiply by factors of 10. For example, if I multiplied a decimal by 10, what would happen to the decimal point? It moves to the right if I multiply by 10. So then what would happen if I multiplied by 100? It would move twice. What if I multiplied by 1,000? It would move 3 times, etc. You get the idea. So the question is, what do I have to multiply by to move all the decimals in this problem enough where I don't have decimals anymore, meaning the decimals move to the end of the number? So right here, if I moved this decimal 1 time, it would be 11, and I'd be doing awesome. But if I move all the decimals 1 time, how's that going to affect everything else? Well, let's check. If I move this decimal 1 time, I'd have 1.0, which is 1. That's perfect. What about here? Oh, here I'd have 2.5 or 2 5/10. That's no good. Moving 1 time is not going to work. I got to move at least twice so that this one isn't a decimal anymore. Does that make sense? Okay. So I'm going to multiply everything by 100. Multiplying by 100 will move the decimal point on all of these. So 0.25 times 100 is 25. The parentheses are kind of protected from being multiplied by 100. I'm multiplying this entire term by 100, so I really only need to multiply the outside number. 0.10 times 100 is 10. Don't have to worry about the stuff in parentheses, it's fine. And on the end, if I moved it once, it would be 11, but I'm actually moving it twice, so what's it going to be? 110. Just like with fractions, we pay a price for not wanting to deal with decimals. And the price we pay is that now all of the numbers are bigger, which is fine. We're okay with big numbers. Some people just really don't like decimals. And if that's you, you can get rid of them, but you're going to have to deal with big numbers. Okay, now that we got that done, what do you want to do next? Besides throw up your hands and run screaming from the building. Distribute, that's a good idea. So I'm going to leave the 25x alone. And we'll do 10 times x and 10 times negative 3. That will give us 10x minus 30 equals 110. Now what? Add the 30, yeah, that'd be okay, but before I do that, there's something I can do. Yeah, I can combine the x's, can't I? They're on the same side of the equals, that's pretty nice. Okay, then what? Now let's add the 30, that seems good. So 35x equals 140. Then what? Divide 35. $140 divided by 35 is 4. I don't like to brag, but I'm really good at dividing by 35. And the reason why is that when I was in elementary school, ice cream at the school cafeteria cost 35 cents. So you got real good at multiples of 35. How many ice creams can I buy today? I know, I'm dating myself a little bit. Ice cream used to be 35 cents. Now it's like, what, $9? If you go to one of those ice cream places where you like make it yourself, like ice cream, like you put the yogurt in, put the toppings on and whatnot, and you make it yourself, it's like $5 or $6.
Oh yeah. That's super expensive.
Yeah, it's really expensive, and I have to do all the work, and then they put out the tip jar, which is gutsy. It's gutsy to make the customers do everything and then put out a tip jar. You gotta admire that. Let me show you a couple of special cases, and then I'll rant about the tip jar at Starbucks for a little bit. I'm just kidding. No, I'm not. This is a special case. It's hard to tell right at the beginning what's special about it, other than it's a nightmare. You'll see in just a minute. So when you get a god-awful problem like this, the first question you should be asking yourself is there anything I can combine? And in this problem, the answer is no. There's nothing on the left or the right that I can combine right off the bat. I'm going to have to do distributive property first. So let's do that. I'm going to do negative 2 times x. That is negative 2x. Now be careful here. Negative 2 multiplied by 5, but there's a minus sign in front. So what's, it's going to be a positive 10. Okay, bring down the plus 10. Equals, and then we'll distribute here. Negative 3 times x. That's negative 3x. And then negative 3 times 2. Negative 6. plus x. What do you think? Yeah, let's add the two tens. That seems like a good idea. Negative 2x plus 20. Great. Then what? Yeah, we can combine these x's. That seems like a good idea. Negative 3x plus x is negative 2x and then minus 6. Then what?
What'd you say?
When?
Just like the last part.
The
Negative 2x minus 6.
negative 3x plus 1x is negative 2x.
Okay. Thank you.
Now what? Like add 2x maybe? Get the x's together. Let's add 2x on both sides. Okay, so these cancel, and I'm left with 20. And then these cancel, and I'm left with negative 6. Okay, that's different. What happened?
Yeah.
This doesn't look right. Why doesn't it look right? What happened?
You got rid of x?
All of our x's are gone.
Yep.
Believe it or not, we did not make a mistake. The x's disappearing are not the result of us making a mistake. We did the algebra perfectly. The x's are just gone. Now, the x's being gone doesn't bother me. What bothers me is after the x's are gone, the thing that I'm left with isn't true. I'm left with 20 equals negative 6. Does 20 equal negative 6? No. Okay, so what does it mean when the x's disappear and we're left with a phrase here, 20 equals negative 6, that isn't true? It means there are no solutions to this equation.
That's crazy.
No, it's defined. There aren't any solutions.
Well, then how did I get 26 equals 0?
26 equals 0 you would get if you added 6 to both sides. You get 26 equals 0. That's also fine because as it turns out, 26 does not equal 0. Write that down, kids. 26 does not equal 0. Anytime you end up in an equation where the x's are gone and the thing you're left with is false, the answer is that there are no solutions. What that means is no matter what value you plug into this equation for x, like if you went back and checked your work, you could check it with any x you could possibly think of, it will never work ever. This problem cannot be solved. Very disappointing. So with that in mind, can you guess what our next special case is going to be? No? No guesses?
What'd you ask?
I said, can you guess what's going to happen on this one?
It's not gonna have a solution.
Oh, you said it's not going to have a solution. It's actually the exact opposite of that.
It will have a solution.
So let's do distributive property. 3 times x is 3x. 3 times negative 4 is negative 12. Equals 3x minus. All right, let's get the x's together. Huh. The x's went away this time, but the thing that I'm left with is true. Negative 12 does equal negative 12. That's true. So you said, I bet this one's going to have no solutions, and it's actually exactly the opposite of that. What's the opposite of there aren't any x's that will work? All of the x's will work.
Oh.
Infinite solutions. So technically, the answer to this problem can be any number you can think of. Is 7 a solution? Yep. What about 6? Is that the answer? Yep, that's one of them. What about negative 43 halves? Yep, that's also a solution. Any number you can think of is a solution to this equation, which is kind of nice. Now you might think to yourself, oh, these are great. That just means I can put in whatever number I want and it's right. No. If you put in whatever number you want, you got one of the correct answers out of a possible infinity correct answers. One out of infinity, or as we say in math class, an F. One out of infinity, not enough. So two special cases that both look very similar. The first was the x's go away and the equation we're left with is wrong. They don't equal each other. That's no solutions. The second special case, the x's went away and the equation we're left with is right. The two sides are the same. That is infinite solutions. And everything else will just have a solution. Does anyone have any questions about solving equations?